The Newton-Raphson method uses the slope of the curve to zoom in on a route far faster than any bracket method. Each step replaces a function with its own tangent line and jumps straight to where that line crosses 0. Start at an initial guess, x0. The tangent line at x0 has slope f prime of x0. It crosses the axis at x1, your next guess. The key property of Newton-Raphson is that the number of correct decimal places doubles with every single iteration. Starting from even a rough guess, you reach machine precision in 5 to 8 iterations. Bisection needs 50 steps, where Newton-Raphson needs 5. This is quadratic convergence. The error is squared each step. The red tangent from x0 at 2 shoots to x1 at 1.636. The yellow tangent from there reaches x2 at 1.53. The blue tangent arrives at x star to full precision. Apply Newton-Raphson to f of x equals x cubed minus x minus 2 with derivative 3x squared minus 1, starting at x0 equals 2. At x equals 2, the residual is 4 and the slope is 11, giving a first step to 1.64. The next correction brings the residual from 0.7 to just 0.06. 3 steps from x equals 2 and already at engineering precision. The root is 1.5214. That is quadratic convergence. Here is the EES implementation. Define f underscore nr for the equation and df underscore nr for its derivative. Inside a function, assignment uses the colon equals operator. The duplicate chain applies the update rule directly. Notice that the Newton-Raphson formula sits inside the loop. The loop runs for a given number of iterations instead of a C-like error-based escape sequence. Now apply Newton-Raphson to a quadratic that arises from a binary vapor, liquid equilibrium, a simplified Raoult's law equation in temperature. Starting at T0 equals 400 Kelvin, the residual is 20,000. The large slope of 350 drives a big first step to 343. After 4 steps, the temperature converges to 328.1 Kelvin, the physically meaningful VLE temperature. The second route at 122 Kelvin is also valid. Try a different initial guess to find it. Both methods start from x equals 2 on the same function. Bisection takes 10 iterations to reach 10 to the minus 3. Newton-Raphson reaches 10 to the minus 15 machine precision in just 4 iterations. The EES functions follow the same structure. F underscore q evaluates the VLE quadratic and df underscore q returns 2t minus 450. To find the second root near 122 Kelvin, change x1 to 50 and press F2 again. 7 iterations are more than enough. Inspect x of 7 in the solution window to confirm t equals 328.1. Paste all 3 blocks into EES and press F2 to try it. Newton-Raphson, Week 1.